Welcome everyone to our free GRE Quant webinar. Whether you're here for the first time or have been to one of our webinars before, thanks for joining us. My name is Andrew and I'm one of the student success advisors here at Ready4. I consult with students, connecting them with courses that best suit their needs, and I'm happy to be able to host today's webinar and give you all a chance to meet one of our talented instructors. So let's get started. A couple of things to know before we begin. You're all muted, so depending on where you are, anything you say out loud might look crazy to those around you, but it won't get our attention. Instead, take a minute to find the question box. This will be an important tool for you today. Any questions you have about the content of today's lesson, the GRE in general, or about our courses, you can type them right into that question box, and we'll either answer them directly or during our Q&A session at the end. Also, when it's time for you to cast your vote, as we're doing in-class examples, you can type your answer right into that box as well. We're going to be sharing these slides, answer explanations, and a handout exploring our services at the end, so don't forget to download those. Finally, this session is being recorded, so be on the lookout for our follow-up email after class if you'd like to view the recording or the handouts, especially if you're tuning in from a mobile device. Okay, here's what we're going to cover today. I'll start by telling you a little bit about what we do here at Ready4. Then I'll pass things off so you can see one of our experts in action. While these free webinars aren't going to teach you everything you need to know for the exam, they provide a solid introduction to the test and a chance to meet one of our instructors and get an idea of what our courses are like. I promise that whatever stage you're at in your GRE prep, you're going to take away some strategies that you can apply and continue to improve on throughout the rest of your practice. If you enjoy this session, stay to the end and I'll jump back on and provide a little bit more information about our courses. We even have a special surprise to say thanks for joining us today, and that's going to be at the end of this session as well. Okay, a little bit about us. Ready4 was started out of MIT back in 2013, and our goal ever since has been to make test prep more affordable and more accessible for students. That's why we offer a number of different prep options based on your needs and your budget as you prepare for the exam, ranging from our top-ranked practice tools, which are designed to measure and adapt to your performance, which makes them even better than a book, to our fully immersive prep courses, whether on demand or live with the best instructors in the industry. We're providing a flexible, mobile-led learning experience to fit the needs of any student, regardless of your location or your background. But I'll talk more a little bit about those services at the end. I want to introduce our instructor now so we can begin the lesson. So today's session will be led by Sarah. Sarah has a 99th percentile score on the test and thousands of hours of experience preparing students for the GRE. She gets great reviews from all of her students. She's known for having a very organized way of delivering her lessons, and she does a great job of getting students to ask lots of questions, which hopefully you'll have a chance to see in this session. All right, now I'm going to pass things over to Sarah, but remember, if there's anything I can help with, I'm right at the other end of that question box. Good luck, everybody.
Hey everybody, my name's Sarah. I'm going to be teaching the info session tonight. Embarrassingly enough, there is a big picture of me up right now, and I'm going to make that go away as soon as I can. All right, cool. So, yep, there we go. There I am. Okay, let's get rid of me. Well, what we're going to be talking about tonight, we're going to be doing a few different topics, all of which are really common foundational topics for the GRE. We're going to be talking about units, places, we're going to be talking about order of operations, and then I think what people are most excited about usually is exponents and roots, because there are a lot of points that you can pick up on this test pretty easily if you just kind of buckle down and learn a few things about exponents and roots, because let's be honest, those are something that you forget very, very quickly when you're out of school. And the GRE fetishizes them. They love exponents and roots. So we will talk about those tonight. Annie mentioned the question box. The question box is the place that we're going to be interacting throughout all of our courses and throughout the session tonight. And if you would type into the question box where you're calling in from. That way we can sort of test to make sure that it's working. I'm calling in from northern part of Texas, the Oklahoma border. So in the United States. So some of you might be calling in from here, but let's see. It's always fun because we get people calling in from all over the world. Alexandria, Virginia. I think we get in Alexandria, Virginia like every time I've done one of these sessions. It's amazing. Louisville. I've been to Louisville. I actually saw the Derby. It was pretty awesome. Charlotte, North Carolina. Columbia. Yeah, Columbia, the country. Okay. Let's see. East Stroudsburg, Pennsylvania. Milwaukee. Somebody found the question box in Mobile and the mobile device. Sayreville, New Jersey. Jay, you got it. Yep, you're calling in from California. That is the question box. Anybody else want to give it a shot? Looks like a few people have located it. Where are you from in California, Jay? Hi, Renuka. From LA. Okay. Great. So anyway, this is the question box. This is how you can ask me questions. You can ask the Ready For staff questions, any of that. And I will try to give you all as much attention as I can. If I don't answer right away, I will try to answer while we're working on the interactive problems. Okay. So you will not go home tonight without your answers. I just might not be able to get to it right away because we have a whole bunch of people calling in tonight. Okay. Sabrina, I got your name there. I don't know where you're calling in from. Cool. Okay, so a few things about the test, and then we will get right on to the quantitative content. It's an extremely long test. You should know that. It's 3 hours and 45 minutes long. That makes this not only a test of your skill, but also a test of your endurance. And so it's very important when you are studying for this test that you do full-length practices so that you can get accustomed to how difficult it is to take a test of this length, okay? You can take the GRE on any day but Sunday. It costs you $205. For those of you who are considering whether you should put money into studying for this test, taking a class, just consider that if you want to take it again, it's $205, and you have all the pain of taking it again. So that's something to consider. A lot of people do end up taking it, being unhappy with their score, and then retaking it, but you might be able to prevent taking it more than once. The essay of this test comes first. Analytical writing is the essay portion. That's the part that's least important generally for graduate programs, but they make you take it first just to ensure that you are brain dead by the time you get to the part that actually matters. And the rest of the sections can appear in any order. So you get some verbals, some quants, and they'll appear in any order. In addition, you'll get the experimental or research section, which doesn't count, and you won't know which one that is. So in any case, they wear you down in every way they can, those folks at the ETS. So you should be prepared for that. Here is the breakdown of how the timing and the scoring works. Analytical writing, like I said, this is the essay. There are 2 essays. One is called the issues essay. The other one's called the arguments essay. They're different. You have 30 minutes to do each. So you start out by doing 2 5-paragraph essays in 30 minutes each. You get a score of 0 to 6 on those essays, and you were scored twice for a total of 12 points. After that, you get a break, and you move into verbal reasoning and quantitative reasoning. And these can come in any order, like we said. You get 20 questions in each of those sections, and 30 minutes for the verbal, 35 minutes for the math. So what this means is you get about 1 minute and 30 seconds for these questions, and you get about 1 minute and 40 seconds for these questions. When we do our practices tonight, I'll be using a time of 1 minute and 30 seconds so that you can get used to the pacing, because that is the other thing to be practiced at by the time you take the test. You want to make sure that you are used to the length of the exam, but also the pacing of it, because the last thing you want to do on the GRE is run out of time. Why is that? Because you don't know that if there might be easy questions at the end of the section, right? And you could get to the end of the section having spent a whole bunch of time on problems at the beginning, and maybe the last few questions are easy, but you just have to go through them because you ran out of time. Okay, so that's why the pacing is very important. These are scored on the 130 to 170 point range. I'll give you a little curve to give you a better idea of what that means in a second, because it's unusual. And like I said, then there's the unscored and the research section. So at the end of all this, you've been sitting there for 3 hours and 45 minutes. Then you'll get a score between 260 and 340, plus you'll get your essay score, which will be from 1 to 12. Okay, and that is it. And you can decide at the test center if you want to keep your score or get rid of it. But that is what your score will be. Okay, so a little bit more about this bizarre 130 to 170 scoring. This represents the distribution of scores achieved on the GRE. If you want to score a 162 verbal or a 164 math, you're going to be in the 90th percentile. That means you did better than 90% of people who take the test. If you just want to score in kind of the lower 150s, you did better than 60% of people who took the test. The median, or sorry, the average GRE score, actually the mean, is a 151 verbal and 152 for math. Now, does anybody know why the math scores are a little higher on the GRE than are the verbal scores? Any ideas? There's a very good reason that the math scores are a little bit higher. This is your chance to be part of the interactivity. Any ideas? Any ideas? Well, so here is the hint. The hint is that the GRE is a global test. Okay, so here okay, these are the answers. This is what I typically see. Okay, so Netanim says because it's easier. Now, Netanim, I'm guessing that you are from another country, or you live in the US, but you are from another country? Is that right? Dennis Porter says, yes, there we go. Okay, so this is great. So Natanim is from another country and says that, yeah, that the math scores are higher because it's easier. Dennis Porter says people aren't very good at math. And it's a little bit like that. Now, Ruthie has something that I think is also very close, which is math doesn't have a language. And yes, that's a nice way to say it, okay? The reason that the scores are higher in math is because the GRE is a global test. And so people take the GRE from around the world. And naturally, because math is the universal language, there's more competition in math, right? You're competing against people from all over the world. Whereas native English speakers have a little bit advantage in the verbal section. And so it's not as competitive at verbal. Now, you might argue that people who were taught English rather than speak it natively have better grammar. And sometimes they do. Sometimes native speakers can be pretty lazy about their grammar. But in general, there's just more competition in math because people take it from around the world. Yeah, so good answers, guys. Yeah, nice. Ruthie, Dennis, Natanim, you all had a piece of it there. That's good. Great, cool. So moving on from this, what can we learn from all this scoring stuff? Like I said, it's important that you leave time at the end of the section because there's no penalty for guessing on the GRE. And the last thing you want is to go through the test, get kind of hung up doing hard questions at the beginning, and then find out that there's like a really easy question at the end and you don't have time to answer it because you got behind, okay? So you want to leave time at the end of the section so that you can do that. In fact, the strategy that I recommend is called take the test twice. And what I mean by that is not pay the $205 twice, but do the easy questions, go back for the hard ones, okay? You have the ability to go back in this test, to put a little mark on a question and go back to it. That's what you should do. And that way you know that you've gotten all the easy ones and you don't get bogged down by hard ones, okay? Ignore the apparent difficulty. This is an adaptive exam, which means that you'll be given a medium difficulty section to start with in quantitative and in verbal. Based on how you do on that section, you'll either get a harder section if you did well, or an easier section if you did poorly. So there is a little bit of adaptation going on, right? Not everybody gets the same test. You might get the hard version or you might get the easy version, and your ultimate score depends on doing not only how many questions you got right, but also how hard the questions were. So this is to say, when you get your second section, you don't have time to worry about whether you got the hard one or the easy one. Just do the questions in front of you because you've got enough to worry about. Don't try to outsmart the test, okay? Finally, practice with the right tools and content. So there are question types that are specific to the GRE. In fact, most of them are specific. The quantitative comparisons are only GRE. The sentence equivalencies are only GRE. The text completions are only GRE. It's important that you are studying with these types of questions. It is also important that you are taking full-length practice tests for the reason I explained before. It's a test of stamina, so you should get used to that. You should take at least three full-length tests. Those are available from ETS. They're also available from Ready For. And if you have the option, try to take ones that are at a computer so that you can get used to the idea of like having to do your work on scratch paper and then go up to the screen. Today I'll be annotating on the screen because that's the only way we can do this. But when you take the test, remember you've got a paper as well as a screen, and you should get used to going back and forth. There's also some particular question types like select in passage that you just want to get used to ahead of time. Okay. All right, so that's all I got about the format and time. If you got questions about that, go ahead and type them into the question box, and I will try to answer those while we go through. But I'm going to get started on content just so we can get rolling and we fit everything in tonight. So Renuka, I see your question, and I will get back to you in just a second. So, like I said, the topics that we're doing tonight are decimals and digits, PEMDAS, and exponents and roots. Starting out with decimals and digits, these should be pretty clear to most people, and I just want to highlight for the folks who are not original speakers of English, there's a difference between what we call the tens place and the tenths place. So everything behind the decimal point, this way, has the TH in it, right? Tenths, hundredths, thousandths, okay? So these are your place values. When we want to round to a nearest digit, we look at the digit after it. So if we were going to round our units place, we would look at the digit after it. And if this digit is less than 5, we round down. If it's greater than or equal to 5, we round up. So how do we round this to the nearest units digit? We look at the 4, we decide it's smaller than 5, so we round down and we keep it at 9365. Okay. If this were 9365.7, we would look at that 7 and we would say, okay, that's big, we're going to round up. And it would become, then in that case, it would become 9366. Okay, so that's how rounding works. Probably review. Cool. Your example, round 7422.751 to the nearest digit, nearest tenths digit. Okay, and go ahead with put your answer in the question box. Okay, so which is the 10th digit? Tenths, the tenths place. This is the tenths place. So we're going to round to that number. Okay. Looks like we're about half and half on this one. Okay. If we want to round to this number, that means we want this to be the last one. So that means we're going to go 7422 point, and then we're going to ask ourselves, what do we want this last digit to be? Well, we look at the one after it. And since it's 5 or more, we round up. So this becomes 7422.8. Okay. 7422.8. Okay, nice. Yeah. Avian, Anthony, Melvin, Melva, Zoe. Looks good. Some other ones in there. Jay, Dennis, Simi, all look good. Look good. Okay. So then we get into a question like this. These are very common on the GRE. You're not going to see like 6 of them on the GRE, but you are very likely to see 2, for example. These are called modern math problems, and this is where they make up a math operation, and then they define what that math operation means in the course of the question. So here they've made up a math operation called C dot, and they're telling us that C dot is what you get when you round C to the nearest thousandth. So for example, let's say that our number C is 0.0015. Well then, C dot is going to be the decimal obtained by rounding C to the nearest thousandth. So what would C dot be equal to? Yeah, exactly, Jess. Yep. Looks good. Looks good. Avrino, Robbie, Natanim, looks all good. Yep. Okay, so C dot is going to be 0.002. Okay. And that's the great thing about these modern math ones. They're usually very easy. These ones, and sometimes you'll see like 2 clubs, 3, or you'll see like 4 diamond, 5, or, you know, they'll come up with something crazy like this. And these are not math operations that you forgot to learn about in school. These are just totally made up for the purpose of the GRE. And the good thing is they're usually really easy because they define what that operation means in the question. And you just kind of have to paste the numbers in. Okay, so they're usually very straightforward. Here, though, we have C and C dot. So carrying on with this question then, our C is not 0.015, it's 0.002. So take a moment and, sorry about that. My gosh, I hit the end. There we go. Take a moment then and figure out, what do you think the answer to this question is? So you can just type into the question box A, B, C, D, or E. Dennis has already got his answer. Okay. Okay, so looks good. Okay, we're getting a range of answers here. Okay, so we have one question. Why was C dot, when we had C is equal to 0.0015, C dot is equal to 0.002 because we're rounding to the nearest thousandth. So tens, hundreds, thousandths, tens, hundreds, thousand. Okay, we're going to round this number to the nearest thousandth. So that would give us 0.002. So that's why we write 0.002. Okay. Right. Looks like most people are getting it now. So the answer is B. Okay. Why is that? Okay. So they're telling us that in this problem, C is equal to 0.00465. C dot is going to be the decimal obtained by rounding it to the nearest thousand. Okay. So Jay, I think this is probably what you meant by Jay. So here, we're going to go tens, hundreds, thousandths. Okay. So our decimal place here, we're going to round it to the nearest thousandth. So we're going to go up 0.005. C minus C dot then is going to be 0.00465 minus 0.005. Now we know that this is going to be negative, right? Because 0.004 something is less than 0.005 something. So automatically we know that these answers are out. Okay. And on the GRE, you get a calculator. There's a little on-screen calculator that you get to use that has a limited number of functions. So you could just type this into your calculator and you would end up with B. Okay. Robbie's asking, does the onths place not exist because it's hard to say? Yeah, I don't know why we start on tenths. I don't know, actually. It probably comes from 10%, like a tens of percents. I don't know. But yeah, onths. I think onths is actually really easy to say. It just sounds stupid. So, okay, so we get to this question. And again, I remind you, you have a small calculator that you can use on this. So you are welcome to use your phone or whatever you need to for now to answer this question. And I'm going to disappear. I give you a minute on this one because it's not particularly hard or time consuming. And at the end of a minute, we'll see what answers we get. Okay, so you got a minute, and I've got a stopwatch here that I use for all my classes right here. Had it for years. And just to keep you honest, your minute starts now. Okay, so that is a minute. Just to prove to you that it's a minute, I've got my watch here, a minute, and 27 thousandths. Okay, so with that, let's see what we got. Looks like we got a bunch of B's, an A, a couple A's, several B's, more B's, lots of B's. Okay, cool. So here's what we do with this problem. Again, we have a calculator, so don't forget that. A lot of, some of the graduate exams like the GMAT, you don't get one. On the GRE, you do, so use it. If we type 1/22 into a calculator, we get 0.0, 1 divided by 22, we get 0.0454545. If you didn't have a calculator, you could do this by long division. You would find out that just the way it works when you do the long division, you would see this, but this 4-5 pattern is going to go on forever, okay? It's just going to go on forever. So 4-5, 4-5, 4-5. It's not like in the 27th spot, it's going to turn into a 1, okay? You can just assume when you see something like this on the GRE that it's going to repeat like that forever, okay? And in fact, in math, the way that we would usually write that is we would just do 4-5 with a line over it, and that indicates 4-5 repeats forever, okay? So that means n is the decimal form of the fraction 1/22. Okay, so we're comparing 1 to the decimal form of the fraction 1/22. We're looking for the 28th digit of this decimal, okay? So if this is n, the decimal form of that fraction, what's the 28th digit going to be in this line? Well, we don't know what it's going to be. It's either going to be a 4 or a 5. And it looks like the 5s are going to be the odd digit places and 4s are going to be the evens ones, but it doesn't really matter. We just know that it's going to be a 4 or a 5. Okay? So with that, 4 or 5? Well, 4 or 5 is greater. So quantity B. Okay? If you picked quantity A, it might be because you misunderstood the question, that you thought you were going to get some kind of decimal and that would be less than 1. But remember, what they're asking for is just the digit. Is it a 4 or a 5? And we're not concerned with it being 45 thousandths or anything like that. Okay? Just asking what is the unit in that place. Okay. All right, so yeah, so the answer to that guy is B. Can I go back to the screen? I don't know what screen. Ruthie, which screen are you talking about? I think it should be showing. Can other people not see the slide? Are other people not seeing the slide? Yeah, Ruthie, I don't know what's going on. I think other people can see the slide. Sometimes something weird will happen, and I appreciate it when you point it out, because sometimes my screen share will turn off, and I won't know it. But it looks like I think other people can see me, so I think you must have hit something on your end. Okay, great, thanks. But thank you for bringing that up. Yep. If you have yeah, I guess maybe if you double click on the video thing, maybe I explode on your screen, which is, Robbie, that's gonna that's something that I kind of wish I could unknow now that you've told me that. Great. It's bad enough having to see yourself on the internet, but now knowing that if somebody makes a mistake, they might see me full screen, like that's particularly awful. Okay. All right, so yeah. Okay, so now we're on to order of operations. I know you all learned this at some point, but the order of operations is the grammar we use in math to make sure that this expression gives everybody the same outcome. So the order that we do math expressions are parentheses, exponents, multiplication, division, addition, or subtraction. These guys, you can mix and match these, and you can mix and match these. So you could do your multiplication or your division first, or your subtraction or your addition first. But the rest of them, you have to go in this order, okay? I've heard a lot of different acronyms from people. Please excuse my dear Aunt Sally is the one I learned. Please excuse my dear Aunt Sally. You might have your own. But however you want to remember it, this is very important. And I ask you then, if you would, to find the solution to this. And this is a great little test because it uses all of the orders of operations. Ah, Dennis, you're already on it. My gosh. Cool. Dennis is already there with the answer. Next, we need someone else. We need someone to confirm him. Anyone else? Anyone else? Okay, yep, not name, Averina. Okay, yep, good. Okay, we're getting confirmation. Yes, everybody's getting the same thing. This is great. Okay, so the first thing we do is we solve our parentheses first. So 1 plus 5, so this gives us 6. So now we've got 2 times 6 squared over 12 plus 9 minus 8. Now we can, so that takes care of our parentheses. Now we're going to do our exponents. So we're going to square this. That gives us 2 times 36 over 12 plus 9 minus 8. Okay. This, we're going to do our multiplication. That gives us 72 here. And then our division, 72 divided by 12, that gives us 6. So our multiplication and our division are done now. We're going to cross out exponents, okay? So now we're just left with 6 plus 9 minus 8. 6 plus 9 is 15 minus 8. That gives you 7. And so the answer is 7. And it looks like most people got 7, okay? So good job on that. All right, moving on. Exponents and roots. So now we get to the good stuff, in my opinion. This is meant to show you that when you have even exponents, you can only ever end up with a positive number. So it doesn't matter if I do 2 squared, I get 4, or negative 2 squared, I still get 4. Same is true for fractions. If I do 1/2 raised to the 4th power, that's the same as 1/16. Same with negative 1/2. If I do negative 1/2 raised to the 4th power, I still get 1/16. Anytime you have an even power, it's always, always positive. It's not true if you have negative, or sorry, it's not true if you have odd exponents. With odd exponents, if you started with 2, raise it to the 3rd power, you get 8. But if you started with negative 2, you get a negative 8. Why? Because a negative 2 times a negative 2 would give you 4. But if you multiply it by a negative 2 again, you end up with a negative 8. So this guy will be negative 8. The same is true for fractions. If we had 1/2 raised it to the 5th, we'd end up with 1/32. If we had negative 1/2 and raised it to the 5th, we'd end up with negative 1/32. So in other words, whatever you end up with is the same sign you started with. If you start with a negative 2, you end with a negative 8. Start with a negative 1/2, you end with a negative 1/32. Always the same sign as the number you started with, okay? So there are a bunch of exponent rules that are worth learning. This is a really, really important slide. It looks like Greek, it looks awful. However, this is one of the most surefire things that you can study for this test because there's a limited number of exponent and root problems. Unlike word problems, which are infinite in their variety and their ways to mess with you, there are only a few ways that roots and exponent problems can work. And so you just memorize these rules, which look a little scary, but you have like money in the bank. You know that they're going to be on the test and you know you'll be able to get them. So these slides all deal with numbers that have the same base. When we talk about bases and exponents, the big number is the base, the little number is the exponent. Base, exponent. So if you want to multiply numbers that have the same base, for example, 2 to the 3rd times 2 to the 2nd, you see how their bases are the same? Very easy. You keep the base and you just add the exponents. It becomes 2 to the 5th. Similarly, if you wish to divide numbers that have the same base, now we're not going to add the exponents, we're going to subtract them. So now we get 2 to the 3 minus 2, which is equal to 2 to the 1st, which is just 2. Okay. Here we added 3 and 2 to make 5. Here we subtracted 3 and 2 to make 1. You can also raise a number to another power. So let's say we had 2 to the 3rd to start with and we wanted to square it. We would multiply the exponents, and that would give us 2 to the 6th. I want to point out that this is different than this. You'll notice here we're taking 2 to the 3rd and multiplying it by 2 to the 2nd, and it gives us 2 to the 5th. Here we are taking 2 to the 3rd and we are squaring it, and it gives us 2 to the 6th. So these are different. Often confused, they're different. Finally, if you raise a number to a negative power, it looks weird, it looks scary. All it's doing is taking the regular number and putting a 1 over it. So for example, if we had 2 raised to the negative 3rd, that would be the same as 2 to the 3rd. We just put a 1 over the whole thing. Okay? So This slide is real important. Pretty painless, actually, in the scheme of things, okay? But again, these only work for numbers that have the same base, All about that base, This is a slide that has pretty much all the same information plus a few more things. It points out that 1 raised to any power is 1. 0 raised to any power is 0. This one's kind of interesting. Any number raised to 0 is 1. So 2 raised to the 0 power is equal to 1. So this is a little bit odd, a little interesting. We did negative powers. We did squaring and dividing. We did raising to a power. We did powers to the -1. And fractions as a power. This one is a little bit different. When you have fractions as a power, the thing to remember, without going into too much detail on this tonight, is that a number raised to the 1/2 is the same as the square root of that number. A number raised to the 1/3 is the same as the cube root of that number. Okay, a number raised to the 2/3, oh boy, that's the same as the cube root of the number. But then what do you do with that 2? Well, you make it a square underneath it. Okay, so this one takes a little bit of work, but that's the fraction as a power slide. Okay, but we covered most of what's on the slide, but this is something worth knowing, well worth knowing. Yes. All right, so now we get to this problem. This problem does not involve the same bases. I love this problem. It's one of my favorites in the whole course. When you don't have the same bases, here we have a 6, a 7, and a 2. It's not all 2s. And we got a 168, and we're like, what is going on? Whenever you see a problem like this, where you have lots of different bases, they always want you to do the same thing, okay? This is just, you know that this is what the GRE folks want, okay? When you see a lot of different bases, try to factor the bigger numbers down to smaller numbers. And reduce the number of bases. Okay, so what do I mean by that? Here we got this 6, a 7, and a 2, and then we got a 168 in it. So I see this 168, and I'm like, what kind of number is that? That's so random. Why is it even in there? Okay, well, I'm going to take the 168, and I'm going to factor the bigger number down. So I'm going to split this into 84 and 2. This is another thing we talk about in the course, is different factoring things, because factoring is your best friend on the GRE. Split it into 84 and 2. This splits down into 42 and 2. This splits down to 6 and 7 and 2. And the astute ones among you will realize, oh my gosh, a 6, a 7, and a couple of 2s. Those are familiar. Okay, so there's a reason this 168 is here. And now we can start feeling like we're kind of on the right track with this problem, right? I'm going to substitute this 168. And instead of calling it 168, I'm going to call it 168 is equal to 6 times 7 times 2 times 2, because it is. Okay, so now the number that I'm looking at is 6 to the 3rd times 7 to the 4th times 2 to the 6th over 6 times 7 times 2 times 2 to the 3rd. Okay, so all I've done is I've taken the 168 and I've replaced it with its factors. All right, with that, now I leave the problem to you. So you've got a minute and a half on this one, and see which answer you like best. Time starts now. That's 30 seconds. You have a minute left. That's a minute. You have 30 seconds. Okay, so that's a minute 30. Looks like I got a lot. I got kind of a mix, a lot of B's, some D's, and some E's. I also had a question, why are we raising it to the third power? So Robbie, we are raising it to a third power because 168 is raised to the third power in this question, okay? So all I did in this first step is I didn't do anything with the exponent. I just took that 168 and turned it into 6 times 7 times 2 times 2, okay? That doesn't get rid of the cubed. You still got to cube it. I just replaced the 168 part, okay? So from there, I'm gonna make some space. Yeah, no, thanks for asking. That's why I'm here. I'm gonna make a little space for us here. Oh, that doesn't really want to erase, does it? Okay. So we've got some distributing to do. First thing is I'm going to take this in 6 to the third, 7 to the fourth, 2 to the sixth, and I'm going to turn this into 6 to the third times 7 to the third times 2 to the third times 2 to the third, right? So I just distributed the exponent to each of these factors. You can do that. That is acceptable, okay? Now I'm going to combine these two, okay? These 2 to the third times 2 to the third. Remember, when you have numbers that have the same base, like these 2's do, and you're multiplying them, you can just add the exponents. So these 2 to the third, 2 to the third, together they become 2 to the sixth. 2 to the third times 2 to the third would be 2 to the sixth. Great. So now I have this fraction where a lot of stuff cancels, right? The 6 to the thirds cancel. The 2 to the sixth cancel. And what I'm left with is just 7 to the fourth over 7 to the third. Now, remember your exponent rules. When you have numbers with the same base, like 7, and you're dividing them, you can just subtract the exponents. So this becomes 7 to the 4th minus 3, which is 7 to the 1, which is just equal to 7. So for those of you who picked B or 7, you're right. Good answer. Cool. I love this problem. I think it's a great problem. Lots of different skills that it tests. Okay, cool. So now we have a quantitative comparison. For this one, this I think of as being a great example of a picking numbers problem. When I say a picking numbers problem, what I mean is it's one where you're just going to pick some values for x and see what happens, okay? So remember, you're comparing quantity A and quantity B. And in these problems, there's a hidden always in here, okay? A is correct if quantity A is always bigger, no matter what x is. B is correct if quantity B is always greater, no matter what you pick for x, okay? So what you want to do is pick a few different values for x to see if it's always bigger, if A is always bigger or B is always bigger. But you got to pick a few values, okay? And the way that I suggest people do this is Panoff. And what I mean by that is pick a positive number, a negative number, a 0, and a fraction if they are allowed by the problem. Panoff, Panoff, Panoff. If they aren't allowed by the problem, then pick some values of different magnitudes, meaning pick a smaller and a bigger, but never just pick one. Never just pick a single value, okay? What do you want to pick? If you're going to pick a positive, negative, 0, and a fraction, what do you want to pick? Pick easy numbers. Oftentimes that's going to be things like 1 and 2, -1, -2, 3, things like that. Depending on the problem, it might be something like 10 or 100, okay? But pick easy numbers to work with and pick more than one. Okay, so with that, you got a minute and a half on this one, and your time starts now. That's 30 seconds. You have a minute left. That's a minute. You got 30 seconds left. Okay, so that is a minute 30. Let's see what we got for answers here. We got a lot of B. Let's see, we got a couple D's, a lot of B's, and one A. Cool. So here is the deal. When you're picking your numbers, again, pick a variety. It's also really important to me neat and organized. And I'm not by nature a neat and organized person. However, you have to be in these problems. So I'm going to set up a table here and I'm going to be neat and organized about it. Okay. I'm going to make big, wide columns because I'm going to be doing my math there and I want to make sure that I've got enough space. This is going to be quantity A, this is quantity B, and this is going to be my value for X. Now they're telling me that X has to be a negative integer. So great, it can be any negative integer. Let's do -1. -1's a good one, right? So if X is -1, then I'm going to get 2 raised to the -1 minus 1, which is equal to 2 to the -2. And if you recall our exponent rules, 2 to the -2 is the same as 1 over 2 squared. So that's 1/4. Over here, I get 3 raised to the negative, or sorry, yeah, 3 raised to the -1. And if you remember our exponent rules, that's the same as 1 over 3 to the 1, which is just 1/3. So which is bigger in this case? 1/3 is bigger. Okay, but we're not going to stop there because you never pick just one number. Okay, -2. All right, if we do -2 up here, we get 2 raised to the -2 minus 1. That's equal to 2 to the -3. That's equal to 1/8, 1 over 2 to the 3. Similarly, 3 raised to the -2 is equal to 1 over 3 squared, which is equal to 1/9. Which one's bigger in this case? This one's bigger. So depending on what value you pick for X, A could be greater or B could be greater. So the relationship cannot be determined. The answer is D. Okay, remember, these are A, you only pick A or B if one is always greater than the other one. Okay, no matter what you pick for X. So the answer is D. Good answer, those of you who got D. Okay. So questions on this one, and then I'll go to the rather painful fraction slide that comes next. Okay, remember you gotta pick multiple choices, multiples for picking numbers, because that's the whole question design is meant to trick people who only pick one number. You just got to know that when you're going into these, the question has been designed to fool people who only choose one number. So you have to pick more than one number. All right, so next from there. Now we get to this whole thing about roots with fractional exponents. These are just ugly and gross, okay? So when you see something that's like 4 raised to the 3 halves, gross, right? We're just going to deal independently with this fractional exponent. So we're going to do the top first, the numerator. That's 4 to the 3rd. And then we'll deal with the denominator. And remember, this one tells you what root you're dealing with. So this tells you the sort of the exponent number, and this tells you the root. So in this case, we've had 4 raised to the 3rd power, but then we take the square root. Okay. Similarly, if we had something like 2 raised to the 2/5, that would be the same as 2 squared, because the 2 is the exponent, but then we would take a 5th root of that number. Okay, so that's how these work. They're commutative, which means that you could do you can do the exponent first or the root first. So if you wanted, you could do 4 to the 3rd and then take the square root. Alternatively, you could do the square root of 4 and raise it to a 3rd power. And you can see how that might be an easier problem to do, right? Because the square root of 4 is 2, and then you cube it. Whereas for cubing it, taking the square root might be more difficult. Okay, but in any case, you end up with the same thing, right? Because if we have 4 root and then we cube it, that becomes 2 cubed, which gives us 8. But if we did it this way, let me get rid of this thing. Okay, but if we did it this way, where we would cube 4, so 4 times 4 times 4 is 64. But then we take the square root of it, and so that would just become 8. Okay. So in any case, that's what you do with these sort of fractional exponents. You deal with the numerator and the denominator separately, and you can do them in either order. Okay, moving on from there. This is a very workmanlike problem, and what I mean by that is there are no tricks to it, but it does test every one of the exponent rules. Okay, I'm going to give you 2 minutes on this one just because it kind of takes some time to work through all of them. But remember what you can remember about your exponent rules. Okay. Yeah. Okay. So I'm going to give you 2 minutes, and your time for this one starts now. That's 30 seconds. You have 1.5 minutes. That's 1:30. You have 30 seconds left. Getting some answers in. Okay, so that's 2 minutes. Looks like we got, good for you, those of you who gave us answers. You know, you remember things better if you're willing to just jump in and occasionally get them wrong, right? There's some that I've gotten wrong while I've been teaching these lessons, and I never get them wrong again because it's so painful. Okay, so P lies between 0 and 1. Which of the following expressions has the minimum value? Okay, so we got to pick a value for P between 0 and 1, first of all. I'm going to pick 1/4. The reason I'm picking 1/4 and not 1/2 is because there's already a bunch of halves in here. And earlier I alluded to my not being a very neat and organized person. I'm just going to try to minimize the number of halves I have on the screen so I don't get confused. Okay, so I'm just going to say P's 1/4. If you picked P's 1/2 or anything else, that's totally fine. I'm going to go with P's 1/4. All right, so now I'm going to look down my answer choices and see what is the easiest one to get rid of. Okay, well, P. Okay, P's 1/4. That's easy. All right, what is the next easiest one? Okay, well, I could do P squared. That's not too bad. So that's 1/4 squared. That gives me 1/16. Which has the minimum value? Okay, well, 1/16 is smaller than 1/4, so it's not E. All right, now they're starting to get ugly because now we're dealing with fractional exponents. But here we've got p raised to the 1/2. Now remember, that's the same thing as a square root. Okay, so I'm going to take a quarter and the square root of it. Now, here's the thing about square roots over fractions. It's the same as, you can always split them up between the numerator and the denominator, and it means the same thing. So a square root over a full 1/4 is the same as a square root over 1 and a square root over 4, like this, okay? Cool, so that just becomes 1/2. That's not too bad, right? Okay, so now we're at 1/2. But 1/16 still has the minimum value. It's still the smallest answer we've seen yet, right? Okay, so it's not all that work, and it's wrong. Bummer. All right, so now we get to this p to the -1/2. I think over versions of this slide deck, this has gotten less and less legible, but that's -1/2. For this, remember that a negative exponent is the same as the exponent, but with a 1 over it. So p to the -1/2 is the same as 1 over p to the 1/2. And the good news is we've already found p to the 1/2. We did it up here. So that's just going to be 1 over 1/2. And what happens when you do get a 1 over a 1/2? Well, again, you could do this on a calculator if you wanted to, but basically you just flip, when you're dividing by a fraction, you flip it upside down and multiply. So this is equal to 1 times 2 over 1, which is equal to 2. So our complete answer for this one actually is 2. P to the -1/2 is equal to 2. That's really big. That's our biggest one yet, so that's not the answer. And then we get to 3/2, and this one's crappy because this is just like that slide that we saw before with the roots and the exponents, and it's kind of weird, but we'll just live with it. P is 1/4, and we are going to take a square root of it because that's the root part, and then we're going to cube it because that's the exponent part. Now, we've already done the square root part. We did that up here. Okay, so the square root is going to be 1/2. And then we're going to cube that, and that becomes 1 to the 3rd over 2 to the 3rd, which is equal to 1/8. So out of all of these, though, the 1/16 is still the smallest, which stinks because it's the second one we did, and we still had to go through all this work. But we did actually need to go through all this work to find out that 1/16 is the smallest of these. So the answer is B. And if you had B, good for you. So now you see what I mean. It's time consuming, and it asks you to know all of your different exponent rules. So it's a very solid problem in that sense. Okay. Cool. So moving on from that guy. This is a nice little trip. Okay, so this was tedious and painful. This is just cool and slick. This is a rule that tells us if you have a situation where your bases match, you can forget about the bases and just compare your exponents. So for example, here we have 7 raised to a bunch of stuff is equal to 7 raised to some stuff. So do you see why this has to be equal to this? 3x minus 5 has to be equal to 4x. Because if you got 7 raised to some things is equal to 7 raised to some things, those things have to be the same. So in other words, when you see a situation like this where the bases match, forget about the bases, just cross them out and compare the exponents. And now that's easy. Now we've just got a straightforward algebra problem. We subtract 3x from both sides. -5 is equal to x. And we have solved for x. We didn't need logs. We didn't need anything weird. We just cross out the bases and compare the exponents. Beautiful. Easy. All right. From there, we have these. So these are 2 example problems for you guys to work on. I'll give you a minute for each of them. You can 2 minutes to do both of them, basically. What you're going to have to do here is not only use that if the bases match, just compare the exponents thing that we just saw on the last slide, but also the idea of factoring the big numbers, okay? Factor the big bases. You want to get down to using as few bases as possible with these problems, okay? So with that, this is a little bit more challenging problem for those of you who had it easy so far. You got 2 minutes, and see if you can get one or both of these in those times. Okay, your time starts now. Okay, so you've got 30 seconds left. Okay, nice. We got a lot of people answering number 1 correctly, and we got a few people answering number 2 correctly, so that's great. Here's how we do the first one. So we're going to factor this big base. So we take 81, and if we factor it down, you find out you get 9 and 9, and this all becomes 3, 3, 3, and 3. So 81 is actually equal to 3 to the 4th. So when we write 3 to the negative 4x is equal to 3 to the 4th. Now we're going to use the rule where if the bases match, we cross out the bases and we just compare the exponents. So negative 4x is equal to 4. Divide both sides by negative 4. X is equal to negative 1. So I saw a lot of negative 1s for that. Good answers, guys. Very nice. This one is a little bit more challenging because down here you want to use 4 as your base, right? Because there's a 4 in it, and 4 times 8 is 32, and that looks like that's the best way to go. It's not the best way to go. The best thing to use here is a base of 2. Now, if that's enough of a hint for you, then you go and work on that on your own for just a second while I explain. But I will start explaining using base of 2. So if I have a base of 2 here, my 4 is going to become a 2 squared to the x power. My 32 is going to become 2 to the 5th. And my 8 is going to become 2 to the 3rd. And remember, I still have to keep these powers. I still have to keep the x and the 3rd powers, okay? Now, what can I do with this? Okay, well, this multiplies out. If you are taking a number and raising it to another exponent, you multiply. So this is 2 to the 2x over 2 to the 5th is equal to, again, you're going to multiply these exponents. That's 2 to the 9th. Okay, so now I want to get this 2 to the 5th out of the denominator, right? That's kind of gross. So if I multiply both sides by 2 to the 5th, these cancel. And what I'm left with here is 2 to the 2x is equal to 2 to the 9th times 2 to the 5th. Again, we have numbers with the same base. When they have the same base and you're multiplying them together, you add the exponents. So we get 2 to the 2x is equal to 2 to the 14th. Now we can just take the rule that says if they've got the same bases, we can cross out the bases and compare the exponents. So we've got 2x is equal to 14 and x is equal to 7. Okay, so Jadzia, Renuka, Simi, nice answers. Good job. X is 7. Well done. Okay, so moving on from this guy. Lots more of this stuff in their course. Now we get to this one. Okay, same idea here. Remember, this one is, we're going to have to deal with this one a little bit like we dealt with 168 earlier. But we're going to be using that factoring rule. And we're also going to be using the rule of crossing out bases, comparing exponents. With that, you got 1.5 minutes and your time starts now. Okay, you have 30 seconds left. Okay, so that's 1:30. Got a couple answers, a couple correct answers in there. Let's see, we've got 4 to the 12th times 3 to the 23rd is equal to 2 times 6 to the z. Oh, okay. Yeah, got Dennis pleading the fifth. We've got Robbie asking if the test comes with ibuprofen, by the way. No, but going to the test is an awful lot like going and getting a drug test. I'll say that. So 4 to the 12th times 3 to the 23rd. Okay, so we aren't going to be able to, we've got several bases here. We've got 4s and 6s and 2s and 3s. We're not going to be able to get down to one base, but we can get down to two bases. So I'm going to change my 4 to the 12th. I'm going to make that 2 squared to the 12th. And there's nothing I can do with 3 to the 23rd. 3 is prime, so I can't do anything with that base. We're stuck with it. I've got 2 over here times, and then my 6, I'm going to turn that into a 2 times 3 raised to the z power. Okay, so all I've done here is I've changed the 4 into a 2 squared. I've changed the 6 into a 2 times 3. When I do that, I'm going to turn this into 2 to the 24th, because again, we can multiply those exponents. Okay, and again, here we can distribute that z. So I'm going to get 2 to the z times 3 to the z. Okay. Now, here's the tricky thing. Here, 2 times 2 to the z. Remember how if you take the numbers with the same base and you multiply them, you can add the exponents. Okay, well, this has a 2 to the 1, right? There's an implied 1, 2 to the first power. So when we add these together, we're going to get 2 to the 1 plus the z. Times 3 to the z. Okay, so these two together become 2 to the 1 plus z. This over here, I'm just going to keep it like it was. Okay, so now the question's asking us, what is the value of z? Well, you'll notice that we have the same bases now. So I'm going to cross out my bases, and I'm just going to compare the exponents. We had a 2 and a 2 and a 3 and a 3. They're gone. Now I've got a 24 and a 23, and a 1 plus z and a z. So looking down my answer choices, doesn't it make sense that we should pick 23? Because if I pick a 23 here, this would be 23, and this would be 24. And that would match my 23 and my 24. Okay. If I picked any of the other answers, I'd get like a 26 and a 27, or a 34 and a 35, and that wouldn't match these exponents. Okay. So 23 is the answer, because that's what we get. That's how we can make the exponents match on both sides. Okay. So A. All right, and then we get into this one. This one you should, if you've studied at all, you've probably seen a question like this. Up until this point, we've been dealing with exponent problems that involve like multiplying and dividing numbers, okay? Multiplying, dividing, that kind of stuff. They will almost definitely give you a problem that involves subtracting. And I'm here to tell you that there is nothing you can do with exponents that are being added and subtracted. There are no cool rules. There's like nothing you can do. The only thing you can do is factor out the biggest thing you can think of. Okay? When you see big exponents being added and subtracted, when you see numbers with big exponents being added and subtracted, there's not much you can do. Factor out the biggest thing you can. Okay? So what do I mean by that? When we say factor out, I mean factor out a big common term. So out of this numerator here, 3 to the 22 minus 3 to the 21. What's the biggest thing we can factor out of 3 to the 22 minus 3 to the 21? What can we factor out of that? It's not the biggest thing, then what is something we can factor out of it? Ah, Robbie, very good. Very good, Robbie. Anyone else? The biggest thing we can factor out of that. And when I say factor out, I mean pull something out and then leave something in parentheses. So put something here and then be left with something minus something. Yep, Renuka, very good. Yep. So Robbie and Renuka are saying we can pull out 3 to the 21st. Okay. Yeah, so yes, okay, so Dennis is asking exactly. So Dennis is asking the right question. Yeah, exactly. So Dennis just went down the road that the test makers want you to go down. What you cannot do, this does not equal 3 to the first, okay? That's not true. Because what equals 3 to the first? Well, 3 to the 22 divided by 3 to the 21 does, because that's when you subtract the exponents and you get 3 to the first, right? But what the test makers absolutely want you to do is to look at that and think, oh, it's 3 to the first, okay? It's not. And that's why I say there is nothing you can do except factor out the biggest thing you can, okay? Don't get tempted to try anything else, just factor out the biggest thing you can. And so what Ravi and Renuka have suggested is, okay, we can factor out 3 to the 21st. We can actually factor out a huge number from this. So if we do that, if we factor out 3 to the 21st, we are left with just 3 here and 1 here. Okay? And if you're not certain about that, then you can always put it back and see what you get. So if we multiplied this back, we'd get 3 to the 21st times 3 would make 3 to the 22nd. And 3 to the 21st times 1 would make 3 to the 21st. Okay, so when we factor it out, we can factor out 3 to the 21st, and we're left with just 3 minus 1. Okay, so I'm going to do that. So we got 3 to the 21st times 3 minus 1 over 3. Okay, so that's cool. Okay, so what can we do now? Well, we've got 3 to the 21st times 3 minus 1, so let's just get rid of this and call it 2, right? So now we've got 3 to the 21st divided by 3 times 2. We can simplify this, right? 3 to the 21st divided by 3. This is the same as 3 to the 21st over 3 to the 1st. When we have two numbers with the same base that we're dividing, we can subtract the exponents. So this becomes 3 to the 20th times 2. Move this so we can see. Okay. So now quantity A is equal to this. This is quantity A. 3 to the 20th times 2. We're comparing that to quantity B, which is 3 to the 20th plus 3 to the 20th. So which are they? They're equal, right? In the one case, we have 3 to the 20th times 2. That's 2 3/20ths. In the other case, we have 2 3/20ths. So the answer here is that they are equal. And I share you this because you will see something like this problem. It might be 7 to the 13th or something like that, but that's the idea. You factor out the biggest thing you can, and that's always kind of where, and then you divide out as necessary, okay? But that is always the strategy for these problems, okay? Okay, so I've got one more problem to show you that's very different in nature. And it has to do with these units digits problems where they tell you what is in the digits place, but they don't tell you the number itself. Okay, so these are a little bit tricky, but they're doable. And I want to show you just how you handle situations where they tell you what is in a digits place, but they don't tell you what the number is. So in this problem, we've got a 3-digit positive integer that has its digits reversed. So my 3-digit number, I'm going to call it hundreds, tens, units. Hundreds, tens, and units. Okay. They're going to take this positive integer and then they're going to reverse it. So this digit is going to become something that looks like units, tens, hundreds. Okay, so if this were 321, it would become 123. Okay, for example. Now, what are they going to do with that information? They're going to add them because it says if the 3-digit number has its digits reversed, the sum of the resulting integer and the original integer is 706. So in other words, we know that HTU plus UTH is equal to 706. That's fine, except now they're going to tell us that the middle digit is 5. Oy. That's tricky because now there's just not much we can do when we don't know the magnitude of the number, right? We don't know how many hundreds it is. We just kind of know that there's a 5 in the middle of it. We don't know if it's 950 something or 150 something. We just have no idea. So how do we handle situations like that? And here's what you do. We have to represent this number as a quantity. And how do we do that? We say, okay, well, a number HTU, for example, a number 321, is going to be equal to 100 times whatever the H is, plus 10 times whatever the T is, plus whatever the units is. For example, if our H is 3, this would be 300. If our T is 2, this would be 20. And if our U is 1, this would be 1. So we'd add 3, 20, and 1 to make 321. Okay? So if you know what's in the digits place, the way to make a really useful number out of it is you multiply the digit by like whatever place it's in. So the H multiplied by 100, the T by 10, and the U doesn't need to be multiplied because it's just individual numbers. Okay? So for UTH, we're going to do the same thing. We got 100 is in the hundreds. We've got a U in the hundreds place. We've got the 10 in the tens place. And then we've got this H in the units place. And we know that when we add those together, they make 706. From here, they've told us the middle digit is 5. Okay? So this is the last piece of information that we need to solve this problem. So I'm going to give you a minute, so I haven't taken all of the fun out of it, to work out what do we do now that the middle digit is 5, and to see if you can come to an answer. I'll just give you a minute because, you know, this might be one where you're like, I don't know, I'm lost already, okay? But for those of you who are looking for a challenge, you got a minute and your time starts now. Okay, yeah, so it looks like we've got some folks saying you add the like terms and form an equation. Yeah, so what we do, we're going to add our like terms. So we add the H's. So we got 100H and an H, so make 101H. Then we got 10T and 10T, so that's 20T. And they've got 1U and 100U, so that's 101U. Is equal to 706. Yep, Renuka, that looks right. Very good. All right, now the other piece of information we have is that this T is a 5 because they tell us that the middle digit of these numbers is a 5. Okay? Yep, so T is 5. So now we get 101H plus 20 times 5, that's 100, plus 101U is equal to 706. We can subtract the 100 from both sides. We get 101H plus 101U is equal to 606. And now they're asking for the sum of the first and third digits so that we have the H and the U. Those are the first and third digits. But let's factor out 101 from this. That's 101 times H plus U is equal to 606. If we divide both sides by 101, so divide out 101, we get H plus U is equal to 6. And that's our answer. Because all they're asking for is the sum of the first and the third. There, okay, there's my screen share not going. Yeah, there we go. Sorry about that. So what we've got here after we've combined our like terms, we've combined the H's and the U's. We've substituted in a 5 for that T because they told us the middle digit is 5. Okay. Yep. And so in the end, we got 101H plus 101U. We factor out 101. We're left with H plus U is equal to 6. Okay. So the answer here is 6. So this is a very challenging problem. This is up in like the upper 160s, like in a 167-ish type of problem. These are tough, okay? Just so you know, but that's what they look like. Okay, So let's finish up with just one more question, and then we will turn it back over to the Ready For staff to talk to you, okay? So one more question of a much more moderate difficulty. Again, you might suspect x is a positive integer. This looks like one we did earlier tonight. This is another picking numbers problem, but I will encourage you to pick more than one number. Pick more than one number, make a neat table, okay? Your goal for these problems is to aim for variety, so pick more than one number, okay? So let's close up with this one. You've got a minute, and your time starts now. Okay, so once again, it's going to be a picking numbers problem. Yeah, it looks like we've got some D's, we've got some A's, and this all depends on how many answers you chose, okay? And this is sometimes, yeah, so it depends on how many answers you chose. We know that x is a positive integer. So the first one I'm going to pick is just x is equal to 1. So if I substitute that in, I get x is equal to 3 to the 1 plus 1, which is equal to 3 squared, which is equal to 9. Over here, I get 4 to the 1. That's equal to 4. Down here, if I get x is equal to 3, then I've got 3 to the 3 plus 1. That equals 3 to the 4th, which is equal to 81. Over here, I get 4 to the 3rd. 4 to the 3rd is 64. So in this case, this one is bigger. In this case, this one is bigger. What about if we do x is equal to 4? Here we get 3 to the 4 plus 1 equals 3 to the 5th. 3 to the 5th is going to be 256. Over here we get 4 to the 4th. 4 to the 4th would be 16, 64. 64 times 4 is equal to 256. Actually, this is, sorry, the first one is not 256, I don't think. Let me see. 256. Yeah, 3 to the 5th is 243. Thank you. Yeah, 243. But that's why we have a calculator to check. Okay, cool. So in this case, the 256 is bigger. So in the first two, A was bigger, but in this last choice, B was bigger. So it turns out that the relationship can't be determined. It depends on what you pick for X. Now, the question I most often get is, how do I know when to stop? There is a little bit of like finesse that goes into knowing when you've picked enough values for X. The clue with this one is that this one is going up by powers of 3, right? Every time you add, your X gets bigger, it's like you're adding another power of 3, right? Here, it's by powers of 4. And so ultimately, this one's going to get bigger, right? Because if this were 3 and this were 100, obviously this would grow a lot faster than this one would. Now it's not, this one's 4, but it's still going to grow a little faster than the powers of 3 would. And so ultimately, B is going to end up bigger. So we know that even if we start with A being bigger, B is going to get bigger. And so it really depends on the value of X that you pick. Okay, so that's how you know to keep going in this problem. But there's a little bit of intuition and practice that comes with knowing how many values of X you need to pick. But it is never one. You never just pick one value. Okay. All right, so that is what I've got tonight. I think we got Ready For staff waiting to talk to you. If you got any questions for me, I'm going to hang out here. I'm going to lurk in the background, like the lurking lurker that I am. And I would be happy to answer your questions. Thanks, Dennis. Thanks, Robbie, for the time and for the jokes. And yeah, so if you would like to, I will hand over now, and I'll just be answering questions in the background. Thanks again, guys.